Hey guys, so last time we made a furnace and we also made ores in the ground. So I think it would take probably too long to show you that again because you have to make a pickaxe and mine the ground with a bunch. But yeah, we did that. Since then, I've done a little or a lot. It was actually um, I've done a good amount of work just cleaning up code, so it didn't change it functionally at all, but it just made it work a little better and made it easier for me to read. So, yeah, that has happened. Today, I hope to make a biome system. So, that could go pretty well or not well, but yeah, let's get into it. I don't know how much I'm going to show you, but we'll see. Okay, so I need to start this by making another kind of Perlin noise thing for the biomes. It's actually going to be two-dimensional for this. So I'm going to say, I'm not so sure this is going to work, but I will, yeah, see how it goes. We'll generate biome map. Okay, so where are we going to generate column data? We're going to actually put it up before we generate the column data. Yeah. Generate biome map. So I think this isn't going to do anything yet, but wait a second. So then in the wait. No, this is the wrong place to have it. Never mind. So I need to put this thing right here. World manager. We're going to have a public enum of biome type. It's going to be ocean equals 0, plains equals 1, forest equals 2, mountain equals 3, desert equals 4. And then actually, so we have an enumerator of this in a world chunk script. We can just assign it a biome type on start. So then we're going to have parameters. These are their chunk size. We're going to have a public int biome type. Nope. Biome type. So this is going to keep the type of biome it is, and then initialize. So this is going to be where it comes in. So biome type. I'm going to set that pretty clearly because it kind of determines where everything is. So biome type equals, then it's going to be math f dots. Actually, we're just going to get a, we're going to make a method for get biome type. So void, or no, actually, it's going to be private int get biome type. So this is then going to tell you what the type of the biome you are. So we're going to have if mathf, actually we're going to have a float. This is going to be, I don't know, float position, I don't know, or we'll call it LOC for location, I guess, equals mathf dot Perlin noise. So this is going to give you actually I'll look it up so you guys can see. So Perlin noise is this Perlin noise is like a procedurally generated file that kind of looks like this. It's just a bunch of gradient of darker spots and lighter spots. So I'm going to use something. So it's going to create something like this, and then use that to make the biome. So I'm going to use two of these on top of each other, actually. One for the wetness, the humidity, and one for temperature, and then overlay them over each other so you don't. So it's just not just like rings of height, which would be weird. So actually, we're going to say, speaking of that, we're going to say temperature. Float temp is Perlin noise. Chunk, what does he call it? Chunk grid position. Chunk grid position dot x. Chunk grid position dot y. And then float humidity, same thing, equals mathf dot Perlin noise. Chunk grid position dot x. Chunk grid position dot y. So actually we're going to multiply all these by another public integer, which is going to be it's going to be a float. It's going to be biome size for determining how big the different bios are. So I'm going to, that's an error here. What? I'll get return 1 second later. Why is this an error? This chunk position. Chunk position 2 and position 2. Oh, that's why, because I didn't finish this line. So it's going to be get biome type. There we go. So biome type equals your get biome type. So then we're also going to multiply these all by the biome size. So biome size times biome size, not times biome type. This is also should be size. What am I doing? Times biome size times biome size. There we go. Okay, so then we need to make, so we'll just say if humidity, say if humidity is greater than 0.9, then what that's going to do is it's going to turn that into an ocean type. So return 0. So then actually, I'll try to just open a Word document and just draw this out. So just to see what it's going to be. So draw. Okay, we have ourselves a graph of this is humidity going up, and this is temperature this way. So with very low humidity and high temperature over here is going to be our desert. Very super high humidity is going to be, this part's going to be the ocean over here. And we need a mountains, so we need to fill this entire thing up. We have mountains, plains, and forest. So mountains are probably going to be lower on the temperature and probably higher on the humidity. So we'll go mountains here. I think plains, low humidity, low temperature. So it's not super. Um, Plains and forest. So I think, oh, and then also let's just do this. So it's also kind of like, so that's like when if it's really hot, then it does that. Then we'll go plains right here and the forest over here. So I think, so yeah. So yeah, we'll just try using this basic graph as a reference. So if humidity is really high, if humidity is, let's say this is 0.5 here, then we'll make it lower, so 0.4. Then this is wrong. 0.4. Then actually really glad I did this. So if the temperature is greater than if not that, if the temperature is greater than 0.9, then we're going to return not -1. Let's see, what is the desert is 4, so return 4. And then if the temperature is greater than 0. I think I probably want more forest than yeah, more forest than mountains. So we have 0. So let's say 0.4. Then we'll return the forest type, which is 2, and then else. Otherwise, so once it returns something in C#, once it returns something, it's not going to run anything else. So let's say if humidity is greater than 0.9 and it returns 0, then it's not going to run any of this. So so once it returns 0, that's it. It's an ocean biome. So that's how I'm using this. So yeah, I don't know how to use else, if, and else if. So basically, if it gets past this and it's not, so at this point, oh gosh. So at this point down here, it already knows it's not greater than 0.9. So then if it's greater than 0.4, return 2. And then the rest is mountains, which is then 3. So then we can just return 3 right there. And then I think after that, if that all else fails, we go, oh, not there, here. Oh, at the bottom. So then it's plains if it's 0.4 higher. So then else, the humidity is high enough or low enough. So then if temp, why do I keep doing the curly braces? If temperature is greater than 0. Say 0.3. No, that doesn't make sense. No, we're gonna make it 0.5. Return 4, and then if it's none of that, we will return I believe it's one, which is a plains, I think. Yeah. Okay, so next thing to do is going to be, it's not gonna act, it's just, now every chunk has its own biome type. So it's not actually gonna look like anything yet, but um, but then you'll be able to see what's going on here. So then we have generated terrain. Now we can go here and look at all of our different chunks. So let's take this chunk, for instance. This has a biome type of 2. So this one is in, yeah, actually, I'm going to look at this. Biome type 2. So far, all seem to be 2. We can get any biome that's not a forest biome. I mean, so far, I guess they are probably all forest biomes. Yes, you can see where it is. It's all forest. So I think that's a bit too large. Okay, yeah, that's too big. So we need to then adjust the biome size. So we actually can do, no, you can't, can you? Biome size, actually, it's 0, and it just stays at 0. So we're gonna make it 1. Then we should get some different 1F, because putting the F at the end of a number denotes that it's a float, which just makes a float is a decimal number. Putting the F behind it there just helps it to calculate better, probably. Let's see what happens there. Get our terrain generated. And I go here. Chunk is type 2. Let's go through them all. We're still only getting 2s. Yeah, that's a bit unfortunate. Why is that? Biome size is 1F. So if you made it larger, then let's say we make it 10. I don't know what that'll do, but oh, it's in pixels, isn't it? Or make it 100. Make it 1,000 just to test to see if it works. And then we can adjust it later. So the biome size is going to be 1,000. This is weird because it actually makes it reverses the size. So higher biome size is going to give you smaller values because of how the math works. It's taking a position from the Perlin noise texture thing. So chunk this is biome type 2. Oh, still 2. What? What? Chunk grid position. Why is that? Are we hitting it at the wrong time? Oh, that's why. Because biome size here is still being set to 0. If I go here then, and instead of making public biome size, we'll make it private. That way it won't be reset to 0 in the inspector. Okay, terrain generated, bam. Okay, chunk, type 2, 2, still only getting 2s. Is any biome type? Okay, I'm gonna actually check this thing. biome size chunk grid position dot x times biome size. Let's see here. Generate column data. Where's the other math f dot pro noise times? What's the noise scale variable? It's 0.0. Oh, it's 0.02. Oh, so what if we? So what if we make it like that? So that's actually really useful. It could make it very. Yeah, that could be good. I thought it was we were going to, we were supposed to get bigger. I guess I was wrong. So posit chunk is type 2. Ugh. Still gives me only 2s. What is this? This is weird. Okay. Yeah. So they're all just Okay, well, I will try to figure this out. I'll get back to you when it's giving me different values for all the different chunks. Well, I think I got it working now. So I made these debug logs down here to track the temperature and humidity values of each type. So we're getting, so then you can kind of go through these, start with the type 0, maybe, just go through it. You're just getting a lot of zeros, but then like, yeah, it's changing the value there. So, they're getting a lot of different biome types. So that's very good. The next thing I'll need to do is make the different biomes act differently. So I make it a scriptable object. So a scriptable object is what I use for all of the stats for the different blocks, but we're also going to make one for a biome. So create a model behavior script, and we're going to call it biome database. Okay, so we got our biome database here. It's going to be a scriptable object. And then it's going to kind of do it like I did this one. So yeah, just all the different values. Oh, it says public list of type. Oh, I see. Block database, biome database. Public list. No, it's at start, I think. No. No, it's not. This is a public calls class. Biome data. That's what no. I'm just biome stats, okay. Biome stats. So then we're gonna have a public float for I don't know if it's gonna be altitude, but what should I call like how high the peaks get? I'll just call it altitude for now. Altitude. We're gonna have a not speed, but it's gonna be a jaggedness. So that's gonna be how like rough the terrain is. we're going to have a public jaggedness 2. Why is it that's the suggestion? Jaggedness 2, really? Public float tree density. I think that's all. And then we're going to have a public list of type biome stats. It's going to be called biome data, I think. I'm just going to kind of copy what I did for block database. Nope, it's. Oh, we're also going to put the screen menu as a thing in there. It's just stats. Okay. It's biome database. Biome database. Okay. Just stats. What was that? Got it. Stats equals new list of type biome stats. Using system dot collection style generic. There we go. Okay. I think that should essentially work. So I should also create a name for it because public string name. Okay. So then we should get in the Unity editor a biome database file that just appears. Assets. Now we will create a biome database. Actually, what is it called? Yeah. Create biome database for, yeah, let's call it that. Okay, so is it not public? What's the difference? Huh? Oh, it's just not serializable. I need that. Some dot serializable. Okay, we're gonna try that, see what that does. Biome database, there we go. Okay, so far we have 5 biome types. Type number 1, name is ocean. Biome number 2, should just look at this. It's ocean, plains, forest, mountain, desert, ocean. So altitude is 0, jaggedness and tree density are all 0. Plains, the altitude is going to be, I think it's going to be about 0.8. That works. Jaggedness is going to be 0. Tree density is going to be, oh, we had more like 0.5. Okay. Forest, tree density is going to be 10 on this one. Jaggedness is going to be, I think it is 0.5. Jaggedness. Altitude is going to be 1. Then altitude on mountain is going to be 5. We'll say jaggedness is going to also be 5, and tree density is going to be 0. Desert is going to be the same. It's going to be altitude of 0.5, same as plains. Jaggedness is going to be, yeah, same jaggedness as plains. Tree density is also going to be 0 though. So yeah, those are all our things. Now the last thing we need to do is in the world chunk script, we get biome type. Now we need to actually implement these things. So world chunk, okay. Header, parameters, world manager. We're gonna set. Okay. Header, it's gonna be called and public. What is it called? Biome database, yeah. So world manager, name, biome database, object. Okay. So then you world chunk. So initialize game object. Biome type equals get to biome type. Generic data is virtually shitty, so go left parameter value, surface height equals base layer height plus method for int, which also multiply into this altitude. So we'll have type of biomes, we should have world manager dot instant. No, yeah. Okay, actually, You just put a thing in this for private things world manager. So just private world manager. So private world manager world yeah world managers world map. I'll call it world map for fun. Okay. Then also initialize world map equals world manager dot instance. Okay, I'm gonna back here. So I'm gonna say float altitude equals world map dot. It's find data dot should be find data stats. Should really capitalize. Right. Anyways, find data dot stats on and type dot altitude. Okay. So there we go. I need to multiply. We're gonna multiply altitude to this. So line alignment altitude. Okay. I think tree density. Tree density. Global X is less than. Apparently, I don't quite understand this, but hmm. You know what? First, we'll just test um the height. So we should see mountain biomes. Mountain biomes getting really high, and other biomes not quite as high, and then this should work. It did not do anything because of course it broke. That's because World Manager needs this biome database right there. Okay. Now it still doesn't. Oh, is it? It did work. Okay. Oh, look at that. We have a mountain biome, I guess. Guess you could call it. Um, yeah, that's kind of absurd. Hmm. Yeah, we have a mountain biome over here. Is any way of? Yeah, that is really absurd, actually. Also want to climb to the top of it, but I don't. Okay, what the heck? Why is there a floating tree? Why are there floating trees? Okay, I'm gonna go investigate the floating trees. Just oh, because this is another type of biome that's lower. Is there a is this two-dimensional Perlin noise? Can't quite tell. Yeah, so it's not generating the trees on the ground. It's putting them. I bet if you looked, there would be if you like mined in there would be trees inside of this mountain, which is not how it's supposed to happen. So yeah. So don't like the sharp cutoff like that. That's anyway. I can. I'm actually gonna just look around, see what. Yeah, interesting. I'm gonna get it anyway. Well, guys, I fixed that big issue with the mountain that's just sticking up out of the middle of. It looks like it's on a pillar of rock. Look at this. We're on the top of a mountain, looking down. It's crazy. Those are other biomes over there. That's like, look at that. That is crazy. Anyhow, I got it working. So, yeah. And now, for the fun of it, I'm going to jump off the top of this mountain and just go that way and see how far I go. Ready? Yeah, I landed at the bottom of the mountain. It's just crazy. It's just great. Anyway, yeah, I think the next thing is gonna be to make the trees not floating. I'm gonna do that, and also make it so that the correct biomes have more or less trees. Okay, so surface height. Where is surface y? Surface height times multiplied by altitude. I'm gonna cut this out and paste it here. There we go. Okay, this should make it so the trees are not any longer floating. Generating, it's loading. There we go. And trees are still floating, aren't they? Oh, it's probably. Oh, they're like really high there. I think that probably has to do with the um, other thing I changed. So I was altitude. What is this? Centered Berlin. That's why. So minus 5. There we go. So I think that should work. Another thing I'm going to do quick is make what am I doing? I'm going to make the mountains only out of stone instead of all the block types. So if um, okay, if it's type 3, I think. So if biome type equals 3, then it's just it's type to places block type dot here. So it's so then if y, so it'll be if y is less than or equal to surface height, then type to place equals block type dots, not sand, stone. Okay. And then I think what else? Is there a desert biome type biome database? No, it's a world chocolate. No, not world chocolate. World manager. So, desert is 4, mountain is 3. Yeah. Okay. It is. Yeah. Type place block type dot stone. If biome type equals 4, then we'll do if y is less than surface height minus 6. So I'm going to put 2 layers of sand at the top. That's going to be type 2 place equals not block type dot stone, but rather sand. Then if it's minus, if it's less than surface height, surface height minus 4, No, sorry, this is stone. Stone. -4 is dirt. And then we'll do 2, I think. Should be capitalized, shouldn't it? 6, we'll make it 3. And then undo that. Oh gosh, I said undo. Duplicate the line. If it's less than or equal to surface height, is block type dot sand. Desand. Nope, just sand. Okay, so this should do. I would just say else. No, else if, then this would just be else. This is for basic planes. And it's also going to be ocean biomes for now because I don't have a water block. So the other 3 are just going to look like this. So I'm going to cut them out, paste them in there, and we'll see if trees are on the ground and if there's stone and sand in the world. Loading terrain. Look at that. Okay, so we got big mountains. And oh, look at that. It looks like there's a desert biome over there. That's so cool. So there's the mountains. And we have sand, and all the trees are on the ground. That's another bonus. I can, like, mine the sand. I find this so awesome. I'm gonna make, like, cactuses next. I don't know. That'll be later, but this is a huge desert. And we've got mountains over there. There's trees in the mountains. That looks absurd, but yeah, now we have to make a tree density thing. So that'll be a little more complicated. I'll show you the result when I'm done with that, though. So here's a bit of a goofy problem I'm having. So it looks like I'm in a forest biome. So the problem is these trees are just like, look at that. There's like huge gaps in the trunk. Luckily, I think I know how to fix that. So just go here and yeah, so I'll say and surface equals. No, yes. Place that there. Surface from these. Let's hope this works. I don't know. Loading. Yeah, look at that. So we're in a forest biome. Unfortunately, we have trees inside of trees. But actually, looks like we have a tree growing out of a tree that's growing in a tree. But yeah, that'll be something I work on fixing some other time. So yeah, we got our biome stuff opened up. But I'm working, so I hope you enjoyed. We'll see you guys next time.